Hi, hello, welcome to the Michael Mapes Show. I'm your host, the one and only Michael Mapes. Today, we're going to be talking about some dimensional theories. Woohoo! Okay, so nothing can't be inside of nothing. So, okay, I'm just going to level. When they ask me, if there isn't a God, how could there be space? I will say, that is a good question. So basically, if nothing can't be inside of nothing, then nothing would be infinitely small. So basically, the essence of this is a point. So this is the zero dimension. So basically this point is getting smaller and smaller the longer we measure it. So let's say that this is like on a number line or something. And today we come by with a ruler, we measure it at 3 inches. And then tomorrow we come back with a digital caliper and we measure it again and we realize that it's actually 2.97 inches or something, or like we just keep measuring it out, it's 3.00001 inches or something like that. You keep going infinitely more specifically, basically. So So the essence of a point getting smaller is basically saying that space gets larger relative to the things inside of it as you measure them through time. So, talking about space, the first and kind of definition of space would be a line. So, a line doesn't actually exist. It's actually a series of points in line with each other. The line is the space that these points make up. It's like kind of theoretical, but it's like a way to describe how these lines are in line with each other. So basically, the essence of a line is that even though these points are getting infinitely farther away from each other, there is also an infinite amount of points making up between the points on the line. So basically, no matter how far any two specific points get away from each other, there's still an infinite amount of points within the line. So I guess space is like just 2 points in line with each other. So these 2 points could be space, these 2 points could be space, like these 2 points could be space. So basically it's just any 2 points is space. So if this is space, then, and this is substance also, I should say, then this is substance. So the essence of this substance, this two-dimensional, that's one-dimensional substance. Like a line twisting is just one-dimensional substance. So the essence of this oh my gosh, I keep saying it. The essence of this one-dimensional substance is that all these dots out here are, well, and inside, the dots are inside the circle too. So basically, all these dots out here, they're regular infinite amount of dots. But within this line, there is like 100 infinite dots. Just a random number. Just any number that's larger than the amount of dots outside is the point. So basically, to kind of describe it better, this circle is kind of like falling in on itself. So basically, there's an infinite amount of points times 8 or 100, I think I said, inside this line. And then basically, as you measure this line, all of these points are coming out and then becoming part of this space while all of this space is stretching out. So basically, when you get to the end of time, then this circle will disappear because the final dots inside of it will spread out and then the space will be even again. So that's kind of the goal. Don't ask me why it's tangled up right now, because I'll talk about it, but the essence of it is just this infinite amount of points. Okay, so if there's another way to kind of think about it, basically pretend like there's this black hole. So as you move towards the black hole, you'll notice that your body starts to get smaller. There you go, that's lovely. So basically, as you start to get towards this black hole, your body starts to seem like it's shrinking. So basically, if we pretended like, okay, the essence of this circle mattering is that this space is not totally in line with itself. So gravity is kind of the essence of a one-dimensional line not being in line with itself. So basically, the gravity of this black hole is like substance creating this bend in this line. And then basically, as we move down towards the point, then the amount of dots within the line start to get infinitely small. So moving down towards this point is like moving inside of this circle, because there's an infinite amount of points within it, and then as you move out, the points become evenly spaced. So, okay, so that is one-dimensional substance. Just the idea that, well, I call it dense space, but yeah, it's just the idea that even though there are an infinite amount of points inside and outside, the fact that the points are tangled up means that there's more points, there's more infinite points within the substance than in the given space around it. Okay, so moving on, we have the second dimension. So just like the second dimension, just like the first dimension is actually just a bunch of dots, and we can think of these dimensions as growing orthogonally to each other. So this line is actually at a right angle to this dot, even though it doesn't look like it. And then this line, this two-dimensional line, is at a right angle to the first dimension. And then the third dimension is at a right angle to the second dimension. So that's kind of how these dimensions grow on top of each other. So basically, this second dimension is a bunch of one-dimensional lines just stacked up on top of each other. So if that makes sense, then this two-dimensional space is a representation of the one-dimensional space stacking on top of itself. So we talked about a circle. So how does the second dimension come into the third dimension? By a twist, I would say. So this is where it starts to get like super theoretical. Don't use any of this on your tests. Okay, this is all stuff that I don't want to say made up, but yeah, I made it all up. Okay, so this light is basically, okay, I should say, well, this photon is a twisting of space, in my opinion. So, okay, before I say that, I should say, all energy, okay, No, I won't go there. Yeah, but basically, all energy, in my opinion, can be described as an inclined plane. Just the space is warping to create a certain inclined plane to move things from one point to another. So this light is kind of like an inclined plane, but within a specific parameter of space. So basically, the energy of this light is kind of going forward, but obviously once it hits something, then the twisting is the inclined plane that we experience with our eyes. But basically, yeah, okay, so the reason that light comes in photons is because on the edges of this light, it's actually traveling more quickly than the speed of light, but so it's going more quickly than the speed of light, and then that turns it into substance. But the whole thing isn't going more quickly than the speed of light, just the edges. And so basically the inside represents kind of this wave. So basically, to get matter, okay, actually I should start with this. I know this is gonna sound super scientific, but I'm not really scientific at all, I should say. So if this sounds like super scientific, then yeah. Yeah, this is all all stuff I made up. Okay. So we got E equals mc squared. Basically, as I wrote over here, that just means grams moving an amount of distance over an amount of time. So it's something you can push within a given amount of time. So basically, it's saying that this energy, which is the amount you can push over time, is equal to the amount of stuff there is times the speed of light. It's saying the speed of light. So basically, it's saying that matter is energy, but the speed of light is squared. So why is the speed of light squared? Okay, so I talked about this photon going more quickly than the speed of light on the edges, but the inside is going the speed of light. So in my theory, basically, when we have matter, it's actually a twisting, it's actually a twisting of the second dimension, but the second dimension can twist in more ways than just straightforward. And so matter is the second dimension twisted into a Mobius strip. So basically, this light is going exponentially more quickly than the speed of light, and that's why the speed of light is squared, if that makes sense. So to put this in perspective with the other dimensions that we've been talking about, okay, lovely. This ring, if you will, is composed of an infinite amount of dots, just a bunch of them. And then outside there's like a regular amount of dots. So basically, similar to how this circle is kind of falling in on itself into the circle, these points are actually tangled up points from the outside just falling into this dimensional kind of ring, if you will. So basically, there is like an infinite, before I say that, applying the first dimension, anything larger than one-dimensional substance, which would be a ring, creates gravity, because the idea that these points are supposed to be in line with each other, but they're tangled up, means that the lines of the regular space understand that they're not in line with each other. So it creates a warp. So basically right now we could pretend like all of these dots are in the same place but just tangled up. They're just pulled, scrunched together. So there's like a super infinite amount of points here, kind of infinite amount of points out here, and then just out in regular space, just a small number of infinite points. So basically, so far we have the third dimension twisting. Wait, is there one more thing? Okay, there is one more thing. This is gonna be super pretend, but you know, I might as well say it just because. So basically, I've been thinking a lot about, about like how I'm saying that that matter is made out of a Mobius strip. You know, like I kind of said that. So basically, how does that really relate? Okay, so if we pretended like this Mobius strip, if you can see it, is actually, like, it's not like a ring, but like the sides of the ring actually come up to the edge, so there's just two holes, but the rest of it is like a sphere. That sphere could kind of, or this sphere, the one that I drew, can kind of represent an orbital for an electron. So why can it represent an orbital for an electron? Well, basically, okay, the two reasons that I have, the first one is if E equals mc squared is light squared becoming matter, and then grams is just telling you how many lights squared you have. So that's like not really telling you anything, that's just multiplying the amount of energy that you have in the form of matter by how much matter you have. But basically, if light squared is matter, then, and this twist is light, then we could consider this twist right here the speed of light, or this twist right here. I know it's like kind of hard to see it, I'm just a bad drawer, but if you could pretend like this is the twist of a Mobius strip just on the edge of the sphere, then that is kind of representative of the electron in this orbital. And then basically this line back here is supposed to represent the proton, which is where all of the space of, or where all of the edges of light kind of meet. And basically in this kind of area back here where all of these edges are supposed to be meeting from the energy of light, that is kind of why light is squared, because it's basically saying an exponential amount of, okay, I should also say, I don't know if I said this already, but energy is an infinite amount of points in my theory. So basically, energy is just representative of points that aren't in line with each other. So this twist would be points that aren't in line with each other, because instead of being like a straight plane, like in line with all of the other dimensions, it's twisted up. So basically, these points aren't in line with each other, and the fact that the points aren't in line with each other is the energy. That is the essence of energy. So, okay, so this is pretty much where the edges of the light meet, or like where the points are kind of self-contained, and so they start from the proton, and then the electron is the twist. I don't know if this is making any sense. Like I said, I kind of made all this up. Okay, but the other reason that it matters is because electrons have a certain spin. So basically, when you have these specific types of orbitals, basically you have to calculate the orbitals like at the same time. So you have to calculate all the up electrons in each orbital before you can calculate the down electron. Okay, so like, I know this is like very, like, so let's just pretend like these are orbitals and this is just a subshell. So you have to draw up, up, up before you can draw any of the down arrows. So if you only have like 5 electrons, then you have 3 up arrows and only 2 down arrows because you had to draw the up arrows first. Basically, the reason any of this matters is because a Mobius strip can twist either direction. So these Mobius strips that we have over here are representative of twisting opposite directions. So that is kind of where I will stop with just this is all very based on my theory, but yeah, if it follows, I guess. If that makes any sense, then I'm going to continue. Okay, so far we've been talking about points that are ultimately in line with each other. Like we could say that all the points in this Mobius strip are in line with each other and that they'll just spread out and become regular space. Well, there's still one more type of tangling up, and that is 4-dimension and up. So basically, and also that is the reason why all of it is tangled up. So, if you will, I'm going to start with the 6th dimension. We have this point, and basically this point represents 0 energy, or the null. So like I said earlier, the more energy you add, then the more points are out of order. So, well, start out of order. But basically, you could say if there's a line here, the energy field at this level has like 10 points that are out of order. I know it's like, doesn't make any sense to say like 10 points because it's an infinite amount of points. But even though it's infinite every time, it's still somehow calculable by the universe. So I'm just trying to explain it with these human numbers that I got. Human numbers don't actually make sense because 10.9 feels like the same number, or feels like just as much of a number as 11. You know, if you were looking at the 10.1 to 10.9 and then 11, each point would feel like the same because they're the same size. Well, this starts to change as we get into unstable dimensions. Sorry, I really should have drawn this other one. So this is representative of the dimensional structures. Ooh, that was pretty bad. Ooh, that was really bad. Okay, we have all the dimensional structures. So basically, this 6th dimension has these different energy fields coming out of it. And so basically, let's just pretend like we're on this energy field out here. So each energy field represents one kind of dimension within the 6th dimension, this up and down dimension. But on the edge of this sphere, if you will, we could call it a peel. I'm so sorry that my drawing is just not lovely. Okay, so pretend like this is a peel from the edge of the 6th dimensional sphere. Basically, we have these space-filling curves, and I am really bad at drawing them, so don't judge me, but here we go. So basically, this line represents the 4th dimension. Okay, I should take a moment to say that we know the 4th dimension is a line because when we experience, we've only had one chain of events. Throughout our life, we've only had one history, one set of starting conditions. So basically, the fact that we've only had one set of starting conditions this whole time means that we're traveling along a linear dimension. So basically, that would suggest that this cycle of dimensional structures is starting over. More specifically, the reason or the starting over of the dimensional structures is the difference between the stable dimensions and the unstable dimensions. So the stable dimensions are 1 through 3, and then 4 through 6, okay, 0 is also a stable dimension, because all the dots are the same size, all the lines are the same size, the planes are the same size, and the cubes are the same size. Well, once we get up to the 4th dimension, things stop being the same size anymore. So the reason for that is, if this is, okay, there's one more thing I gotta say. So the reason it's on a space-filling curve is because each time the line changes directions, that represents a different dot, or a dot being in a different place. But the dots that exist within the line represent all the dots in the same place, but with different orientations. So basically, if we had these two balls and they had some sort of energy coming at each other, then we had these two and we had this energy. Ooh, that is mediocre. Okay, these two scenarios have the same amount of energy, but they last for different lengths of time, because these balls bounce off each other and these balls never touch each other. So basically, the amount of interactions is longer with this one than this one, even though there's the same amount of energy. What that is saying is that along this line, if we zoom that in, all of the points that represent the starting conditions are different sizes. So we have these different lines. And we could say that we are like this line if you wanted to be pretty optimistic. Basically, we're traveling perpendicular to this 4-dimensional line. So the 4th dimension is actually the representation of all of the possibilities, and we exist within a single point along that line. So basically, the reason that all of this kind of matters and how it affects us is because the only reason that these dots are, that these dots represent lines is because they're different sizes. And the different sizes are based on the fact that different conditions can result in different lengths of time. So basically, as we're saying this, then we're saying that the 4th dimension and up are kind of wobbly, based on the fact that no matter the starting conditions, if the points are even in a slightly different orientation, it changes how long how long the timeline is. So basically, why do we experience stuff? Well, the 4th dimension starts out tangled, but it wants to be stable. So as we move out from this line, then basically the 4th dimension is trying to even out into 3-dimensional space. Or if you wanted to picture it from our kind of perspective, the starting conditions represent a tangling of space. And then basically, as we're moving through time, all these things are interacting with each other. But ultimately, all of these things that are interacting with each other are going to eventually end up in a specific place. And as they end up in a specific place, space will continue to expand. Like, all the points will continue to be getting farther apart. So basically, all of the things that end up in specific places will evaporate, if you will, as the points find the place that they were supposed to be. So instead of thinking like a ball traveling through space because energy is applied to it, I kind of think of it more like the 3-dimensional space is kind of twisted up into this ball.